Hello all. Sorry I'll be missing you guys for the rest of the summer. Um, just want to give you guys a little intro. This first packet that you see posted down below, you guys can open the one that says Pythagorean Theorem. Intro to Pythagorean Theorem. This is going to be our first topic that you guys missed. So you guys missed a little bit finishing up the quadrilaterals on Friday, but don't worry about that. You guys will just pick up on where we started yesterday, which was with the right triangles. So for Pythagorean theorem and in a lot of these chapters, there's some work with radicals that you guys want to be a little bit comfortable with. We're not worried about radical form, but I do want you guys to be comfortable with operations with radicals. So let me just scroll down a little bit. I'll just put a little bit about working with radicals when it comes to multiplication and division. We're not going to worry about simplifying the radicals completely. That'll take a little bit more time than it's worth for a summer school schedule. But when it comes to multiplication with radicals, we have basically 4 different situations. If we have a number, let's say, well, I'll just put a letter to stand for it. Let's say a, and then we have a times the square root of b. As long as they are both not under, one's not under and one is under the radical, then we can multiply them, but we can't actually multiply them. So let me explain what I mean when I say that. That probably makes no sense. All we can do is bring them together like this, a root b. It's kind of like if we had 8 times x, it's just going to be 8x. We can't do anything more with it. So if I had something like 7 times the square root of 6, this would not become a 42 at any point. We would not actually multiply the 7 and the 6 together. All we could do is bring it together as 7 root 6. Are we multiplying it? Yes, but we're not well, we are multiplying, but what I mean, we're not multiplying the actual 7 and the 6. All right. The next situation will be if we had something like a. Let's say we had a root b times root c. If we had a root b times root c, we're going to end up with a root b c. The b and the c can be multiplied because they are both under the radical. So as long as they're both under the radical, they can be multiplied by each other. All right. So give you a quick example of that. Let's say we had something like 4 root 5 times the square root of 6. If we had 4 root 5 times the square root of 6, this answer would be 4. Because the 4 would not be multiplied by the 6 because the 4 is not under the radical. But the 5 and the 6 can be multiplied. So our answer will be 4 root 30. All right. Next example will be if we had something like a root b times c. In this case, the c is not under the radical, so we can multiply the a and the c, but the b would remain under the radical by itself. So we would have something like, for example, 6 root 3 times 5. In this case, this would be 30 root 3, because we can multiply these because they're both outside the radical, and the 3 would have to stay by itself. We cannot multiply that 3 by the 5 because it's not under the radical. All right, so this would be our answer for that. Now the last situation would be if they both had something under the radical and they both had something outside the radical. In this situation, we'd multiply the a and the c. So the outside numbers or variables will be multiplied, and then the numbers underneath the radical will be multiplied. So we would end up with AC, a times c, and then radical b times d. So a quick example of that would be something like 2 root 3 times 7 root 5. And in this case, we can multiply the 2 and the 7 because they're both outside of the radical to get the 14. And we can multiply the 2 things underneath the radical, the 3 and the 5, and we get the square root of 15. So our answer would be 14 root 15. All right, hopefully that's a little bit of a summary of that. When it comes to division with the radicals, it's really not much to it. Again, we're not going to go deep into it. I'm going to keep it simple for this. If we have something like, I'm just going to put a real number here, not worry about variables. If we have the square root of 20 over the square root of 5, actually, let me not pick 5. That would be a different situation. Let's say over the square root of 2. If they're both under the radical like this, then we can go ahead and divide them. Just like, if they're both under the radical, we can multiply. Here we can divide these. We're going to end up with the square root of 10. We'll just divide the 20 and the 2. The same thing would go if we had something like this. Let's say we had 10 over 5. And they're not currently, it's not two separate radicals. We can go ahead and divide this. This is pretty much the same as what we had up top. You can separate it and write it like that and then say root 2. Or you can just go ahead and divide it at this point and say root 2. All right. So that's pretty much as far as we're going to go in terms of the division and the multiplication. I guess let me give you a division one or so where we have some mixed situations. So let's say we had something like, let's stick one over here. Let's say we had something like 8 square root of 12 over the square root of 6. Now in this situation, you can't you can't divide the 8 and the root 6 because one is under the radical and one is outside the radical, similar to the multiplication. But what we can do is we can divide the root 12 and the root 6. So we would end up with 8 root 2 for this answer. All right. Same thing would go if we had it the other way around. Let's say we had 10 over the square root of 5 divided by 2. Actually, let me put like 50 so it's a little clearer that we're not going to divide it. So we had something like this. Again, we can't divide the 50 by 2 because 2 is not under the radical and the 50 is. But we can do the 10 divided by 2. 10 divided by 2 would be 5. And we would keep the root 50 as is because, again, we can't divide the 2 into that. All right, so this is just a quick sample of some of these. Let's go up top and look at a few of these practice problems with some of the radicals. Again, some of these are doing a little bit more than what we're going to do, so I'm going to skip a few of them. Just want you to be a little bit comfortable with them. The first section with the Pythagorean theorem, it's not as radical for it because we're not going to worry about simplifying the radicals. But the next section that we're going to see the video on right after this is going to be the specials. And with those, there is definitely more radical work. So just try to get comfortable with it. For this first one, we can just go straight on ahead and divide. Root 10 divided by root 5 is root 2. And it will stay under the radical. All right. Let's move on down. The rest of these we're not really going to do. Let's look at number 8. For number 8, just to show you, we could multiply these. We'd get root 30. They're both under the radical, so we can multiply them. For number 9, the 3 and the 5 would be multiplied because they're both outside the radical. We would get 15. And we can multiply the 2 and the 8 because they're both under the radical. We get 16. Now, for a problem like number 9, though, we can go a little further with this, and this will be something I would want you to do. We're not going to be formally, again, simplifying radicals, but you guys should know that the square root of 16, well, you should know 16 is a perfect square. Let me put it that way. 16 is a perfect square. The square root of 16 is 4. So really, this is just 15 times 4. So if it is a perfect square, you should simplify that. So 15 times 4 is 60. So for this one, my answer is 60. Next problem, number 10. Root 10 times root 14 will be root 140. That'll be enough at this point for that. For number 11, feel free to pause the video and try it yourselves, guys, and see what's going on. But for this one, you would multiply the outsides, so you get 18. And then you multiply the unders. It's going to be 18 root 50. And again, we're not simplifying radicals, so I'm good to go. Leave it like that. Now, some of you, depending on the device or the calculator you might be using, it might be breaking down these radicals further. And that's a whole nother thing, again, that we're not going to really get into right now. But let's say, for instance, that your calculator, if you are using one, says 90 root 2. Your calculator is not wrong. Your calculator is simplifying the radical, which is the 18, times the square root of 25 times the square root of 2. Square root of 25 is 5, so it's 18 times 5 root 2. So again, it's not wrong, but I don't want, just in case you are putting your calculator and you're thinking something's wrong with what your calculator is giving you, it's fine to go further in simplifying the radical. You don't have to. And this is 16. 256 is a perfect square. If you just put it in the calculator, that is 16. All right, so let's get to what the Pythagorean theorem is. Most of you guys are already pretty comfortable with the Pythagorean theorem. Hopefully, you've done it in middle school. You might have touched on it a little bit in Algebra 1 as well. But the Pythagorean theorem is the following. It's a squared plus b squared equals c squared. And we use this Pythagorean theorem. We use it for right triangles only. And we use it to find missing sides. We use it to find the length. We use it to find the length of missing sides. When it comes to Pythagorean theorem, just a little bit of background on it. So let me give you guys a little bit. This is my right triangle. Just like with our isosceles triangle, it was important to know, what were the bases, what were the legs. When it comes to the Pythagorean theorem, it's also important to know, which sides are which. When it comes to the Pythagorean theorem, the legs are going to be our A and our B. And the legs are always going to be the two sides that form the right angle. So you can think of it as touch or form the right angle. Legs are the two sides that touch or form the right angle. So by form, what I mean is that if I'm looking at these two sides, A and B, this is A. This is, I'm sorry, that's B. This is A. And these are the two sides that together meet to make that right angle possible. So that's what I mean by form that right angle. All right, so these are our legs. Now, in the formula, it's not like it's just in some random alphabetical order. It's important that your A and your B are on the same side. The legs must be on the same side. And then the other side, which is referred to as C, is going to be our hypotenuse. Our hypotenuse is defined as the side in a right triangle that's opposite the right angle. The side opposite the right angle is our hypotenuse. So this is our C. So it's very important that the C is always isolated. It should be by itself. And when it comes to our hypotenuse, just a few things to note about it. The hypotenuse is always going to be the longest side. So if you are doing a problem and you end up getting that A is 30 and C was 20, you know you did something wrong because, again, the hypotenuse should always be the longest side in any triangle. So our hypotenuse is our longest side. And let's do a few applications where we use the Pythagorean theorem. So I'm going to give you guys two quick examples here. All right, so let's start with example 1. For example 1, let's say this is 7. This is 18. Let's make this here 18 for this one. And I want to find x. And for this one, All right. So take a second to copy these first two examples. And let's go ahead and practice with these first two. So for our Pythagorean theorem, again, we use it when we have a missing side, when we're trying to find a side for the length of a side in a right triangle. Now, we can only use Pythagorean theorem when we're missing one of the sides. So in this case, for example 1, this is a prime example where we're going to use Pythag. First thing you want to do is you want to decide whether the side that's missing is a leg or the hypotenuse. That's going to be important because you know whether you should plug in for A or B, or you know if you should be plugging in for C. Again, it's different. Can't just put, a lot of students just always think they can just put the two numbers in the first two spots and it'll just work itself out. That's not true. The hypotenuse has to be the isolated side. So A and B, when it comes to the two legs, it doesn't matter which one you put first. So I'm going to do 7 squared plus 18 squared equals C squared. Again, the C is definitely the side that's missing because that's the side opposite the right angle. It's the side that doesn't touch the right angle. That's another way to think about the hypotenuse. It doesn't touch it. It's not adjacent, etc. Has nothing to do with the right angle. It's just opposite. So now I'm going to go ahead and solve. To solve this, it's going to be 49, because that's my 7 squared. 8 squared is 324 equals C squared. The next thing I'm going to do is go ahead and add the 49 and the 324. When I add the 49 and the 324, I get 473. And that's equal to C squared. I'm sorry, where did I get 473 from? 373. And that's going to be equal to C squared. So now again, I don't want C or X in this case. I don't want C squared. I want C. So I need to take the square root. The opposite of squaring something is to take the square root. So I square root both sides. I end up having to do the square root of 373. And my answer is going to end up being 19.3. In the package, you're going to see a lot of mentions that say, leave your answer in radical form. For us, again, for summer school with the faster schedule, we're not going to worry about radical form. You're allowed to just put the decimal. So you want to just make sure you practice your rounding, etc. But this answer is going to be 19.13, which is the same as just 19.3. Anyone have a question? Why did I ask that like I'm in class? Sorry. Have it, guys. Ask me questions. Well, you can't at 4 o'clock, but not now. All right. So let's move on to the next problem. For the next problem, number 2 here. For this one, we want to figure out x. So again, the first thing you want to do is determine whether that is a leg or the hypotenuse. For 2, this is a leg. So being that it's a leg, it doesn't matter whether we plug in for A or B. The legs are interchangeable. It's no different whether we put it in either spot. So I normally just put it first. So I'm going to go ahead and put it in for A. So this will be x squared plus, this is my B, 16 squared, equals my C squared. So I'm going to do x squared plus 16 squared is 256. 24 squared is 576. I end up with x squared equals, let me just write out the extra steps here for you guys, at least the first time through. What I want to do is now I want to solve for the x, so I'm going to move the 256. So I end up with x squared equals 320. Take the square root of both sides. Square root of 320 is going to be 17.88. So I'm going to round that to 17.9. All right, so before we do the next thing that's written on this page, the converse of the Pythagorean theorem, let's go to our next page and do a little bit of practice. Again, we're not going to be worried about doing any real radical work, so we can get rid of that. And I would say you guys pause your videos, take about 3-4 minutes, and try to do letters A, B, C, and D here. Again, you want to round to the nearest tenth. So again, at this time, pause your video, try those problems. Next time you play it, the answers will be up. All right, guys, so let me scroll back up so you can see all four. So these are my answers to those 4 problems. Hopefully you guys gave them a try and you were able to come up with these answers. My final answers are the ones circled there. Anyone have a question? You guys could have questions, sorry. Anyone have any questions, feel free to come through to the extra help session. I have like a big tutoring session from like 2 to 4 on Tuesday, Wednesday, Thursdays, so I won't really be available for any type of extra help until like 4:30 on Wednesdays. But again, if anyone, I'm gonna post a link at the top like for extra help today, so if anyone feels like they need some extra help, feel free to come in there at about 4:30. I posted for the 2 exit cards to be due at 6. If you need a little bit more time, that's fine. But if you're having any question about anything, make sure to come in to the extra help before you submit anything, and before you start the quizzes. Before you start the quiz on these 2 topics. All right. So let's do the last one together. The last one here says to find the length of the diagonals of a square if its side is 5 inches. So for this one, this is kind of going to connect to what we just finished with the quadrilaterals. So if you have a square, first of all, we know that's 4 sides. So hopefully everyone can get some semblance of a sketch of a square. So we've got a square here. And if we know from our definition, again, we just finished up with our quadrilaterals, that the square by definition has 4 congruent sides. So we should be able to mark all the sides congruent. And it says here that find the length of the diagonals of the square if its side is 5 inches. So if one side is 5 inches, then that means that all of the sides are 5 inches. The other thing we also know about the square is that it has the 4 right angles. All right, so this is what we've got. Now it says to find the length of the diagonals. It doesn't necessarily need to indicate the diagonals because the diagonals are congruent, remember, in a square. But basically, we just need to find the length of one of the diagonals here, since they're the same. So that's what we want to find. We want to find x. Now, what you are going to utilize to figure that out is the fact that this right here is a right triangle. And in order to find the diagonal, I can use Pythagorean theorem. So it's going to be 5 squared plus 5 squared equals x squared, because that is this diagonal is x. I'm sorry, it's the hypotenuse. So it's going to go in the C spot. So it's going to be 25 plus 25 equals x squared. That's 50 equals x squared. The opposite of squaring is the square root, so we square root both sides. And we end up with x equals, I think that's like 7. Square root of 50 is 7.1. It's 7.07, and we're going to round to 7.1. All right. So I'm going to move up and do the last piece of this Pythagorean theorem packet. So the last component of this Pythagorean theorem concept that we need to cover is the converse of the Pythagorean theorem. Now, this is something that you probably definitely haven't done. It's probably pretty exclusive to geometry. Everyone's done the Pythagorean theorem at some point. To what detail, that varies, but the converse of the Pythagorean theorem you have not. What the converse of the Pythagorean theorem is useful for is we use this used to classify a triangle by its angles when given the length of the sides. When given the length of all the sides. All right. So, this converse of the Pythagorean theorem is used to classify a triangle by its angles when given the lengths, I should have an S there, the lengths of all three sides, of all the sides, all three, all. Now, that probably doesn't make any sense to you because it does seem like it's backwards. So, for example, if I told you that a triangle had these sides, 10, 6, and 7. Now, hopefully, no one would have a problem classifying this triangle by its angles. By its angles, I'm sorry, not by its angles, by its sides. By its sides, that should be simple enough. So by its sides, this triangle would be scalene. Remember, scalene is a triangle with no congruent sides. But that's not what this converse of the Pythagorean theorem says. It says it's used to classify a triangle by its angles. So remember that angles, that's when we're going to use those acute, right, or obtuse names. Now there's one more which is equal angular. We can't really get that specific with this, but we can. I'll explain it to you in a second, how we can figure out that piece. All we're going to basically do is just say whether it's acute, right, or obtuse with the converse per se. There is a way to know it's equal angular, but it's not using this converse. Now, what you're going to do is the following. If a triangle is acute, you will know because your c squared is going to be less than your a squared plus b squared. If a triangle is right, you will know because your c squared is equal to your a squared plus b squared. And if a triangle is obtuse, you will know because your c squared is greater than your a squared plus b squared. All right, so let's put this into work. So if I give you 10, 6, and 7, these are the sides, it's scalene. Now, I'm asking you to determine whether this is acute, obtuse, or right. Now, what I was alluding to earlier is that obviously this is not equal angular. The way you would determine whether it's equal angular would be if it's equilateral. So if it was, remember, if you had like 7, 7, 7, then that's an equilateral triangle. And remember, if it's equilateral, then that's how you know it's also equal angular. So that's how that will come up. All right, so it won't be over here, but it's definitely a way to figure it out, but it's not going to be necessary to write that over here with the converse of the Pythagorean theorem. So when it comes to using this converse of the Pythagorean theorem, what you want to do first is determine which side is C. Now, think about it. We talked about this when I introduced the Pythagorean theorem a second ago. I said that the hypotenuse is the side opposite the right angle, but most importantly, it's going to be the longest side at all times, and it's our C. So even if this triangle isn't right, if it was right, which is basically what we're trying to see, what type of triangle it is, then this would be our C value because our hypotenuse is always the longest side, and we have 10, 6, and 7. 10 is obviously our biggest side there. So 10 is our C. So that's the one I'm going to put first in my inequality over here. So I'm going to say 10 squared. And I'm comparing that to my 6 squared, and my 7 squared. Again, the order of the a and the b squared is irrelevant. The only thing that's important is c. Which one is c? So we end up with 100 when we square this. 6 squared is 36. 7 squared is 49. 36 and 49. That's going to add up to 85. So we end up with 100, and 100 is greater than 85. So let's go back to the converse. The converse said that if your c squared is greater than your a squared plus b squared, then you automatically know that the triangle is obtuse. All right, let me give you another example 2. For example 2, let's take these side lengths. Let's take 8, 12, and go with 4 root 8. 8, 12, and 4 root 8. And same question, I want you to classify this triangle by its angles. So if I looked at this, first of all, by its sides, it's scaling. Not that you were asked that, but that should be a simple question to answer. It's scaling. Now I need to determine if it is acute, obtuse, or right. So I'm going to figure out which one of these is C. Now, for this one, you should not be just guessing and saying C is 12. Most of us are probably just guessing and do that. You should actually do the math here. So in your calculator, do 4 times the square root of 8. And let's see if that's actually going to be less than 12. Again, you don't want to guess. So 4 times the square root of 8. When I did that, I got 11.3. Now, that 11.3 is not what I should be putting in my squaring and stuff like that, but it is important because it tells me that it's not C, because 11.3 is less than 12. So this is my C. So now I'm going to move on and start my Pythagorean theorem. Start my converse of the Pythagorean theorem. So it's going to be the 12 first, because that's my C value. And I'm comparing that to 8 squared plus 4 root 8 squared. Now, guys, I suggest you practice how to do the 4 root 8 squared in your calculator, because you want to get an exact answer. You don't want to be using these decimals, because the decimals don't seem like a big deal with some things, but with these, if it's not exactly equal when it's supposed to be, we won't know it's right. You could end up with something like, 11.8 and then 12 when they really should have been equal. But because of using an approximation, it's not going to come out equal. So you want to use exact values. So how you put that in the calculator? You'll use your parentheses. You put the 4 square root 8. Make sure you press the over arrow so you don't stay under the radical with the parentheses. Close this, and then you put your squared in. So let me do that on my own just so I can tell you guys what I'm going to get. So for this, I get 144. 8 squared is 64. 4 root 8 squared, that's going to be 16 times 8, that's going to be 128. So the last thing to do is to state what type of triangle it is. I'm going to add these up. It's going to be 144. And this is going to be 32, 92, 192. Any questions again? So this is less than this is acute. All right, so let's move through. I'll do a couple more problems I'll pick before we move on to the next packet. All right, so on page 3, it's much of the same. We did this whole page in class. I think I gave you the students 5 minutes. I'm going to look over a couple of the word problems with you and maybe a few of the other Converse of Pythagorean Theorem problems. Number 5, word problem. It says Mary walked 5 miles north. North is up, so we're going to go 5 miles north. Then she walked 6 miles west. West is going to be straight like that. So this is 5 miles north, 6 miles left. Then we want to close this off. The reason we want to close this off is it says how far is she from her starting point. So this is where she started, and this is where she is now. So the shortest point is going to be that diagonal, not going all the way back 6 and then 5 down. So now I need to do my Pythagorean theorem to figure this out. (25) plus 36 equals x squared. It's going to be 61 equals x squared. Square root of 61 is 7.8. All right, let's move down to the next one. Number 6, it says a triangle has sides of length 9, 25, and the square root of 706. Is it acute, obtuse, or right? So we got 9, we got 25, and we got the square root of 706. First thing you should ask yourself is which one of these sides is C. So in order to figure that out, take your calculators and just do the square root of 706. See what it ends up being. Square root of 706 is 26. What's it? 25. 26.6. So because it's 26.6, that means that the 706 value is the C value. It's the biggest side. So I'm going to put that in first. So it's going to be the square root of 706 squared. Again, I'm putting my empty box because I don't know whether it's less than, greater than, or equal to yet. And then I have 9 squared over here and then 25 squared. Now put this in your calculator because, again, we want exact answers, not rounded stuff. So you should have left it as the square root of 706 squared. A square and a square root are opposite operations. They cancel each other out. So I just end up with 706 equals 81 plus 20. 81 plus 625. 81 plus 625 is equal to 706. Oh, put the equal sign to it. Any questions? They're both 706. They're equal. If they're equal, the triangle's right. All right, I'll post the notes from class. We did a lot more things in this packet. I'll move on and do 1 or 2 more word problems, but I'll post the ones from class that we did. For number 10, is this a right triangle? Again, you want to do the same thing. Use the Converse of the Pythagorean theorem. Let's look at something like number 7. Took some time to do number 7 because it has a radical in it with the Pythag. Just want to make sure you guys are comfortable with those. Let's do 7 and let's do 13 here. All right. Excuse me. For number 7, sorry, number 13. Do that one first because it's top of the page. For number 13, first thing I want to do is decide which one of these is C. So obviously between 2 and 4, I know it's 4. But I need to do the 2 root 3 and see what that's going to be. 2 root 3 is only 3.4. So that means this is my C. So let's begin. So when I start here, I'm going to have, sorry, just trying to clear some space. So I know my 4 is going to be C. So it's going to be 4 squared, empty box, 2 squared, plus 2 root 3 squared. 16, 2 squared is 4. And then over here we'll end up with, again, practice keying that in your calculator. When you do all of that, you end up getting 12. Next thing, you end up with 16 equals 16. This triangle's right. All right, next one we'll do is, again, number 7. Take a second to copy that one if you didn't print out the packet. Now for number 7, now for this one, it's already set up for our triangle. And we need to use the Pythagorean Theorem. My bad, I closed the window by mistake. So using the Pythagorean Theorem, it's going to end up being, this is either A or B, one of the legs. So x squared plus 12 squared equals 8 root 3 squared. This is x squared, this is 144. This is going to end up being 64 times. It's going to be 192. Subtract the 144. I get x squared equals 48. Square root of 48. 6.9. All right. For the word problem page, I'm gonna just post these just because the time already at like 40 minutes. We had some homework in here. I'll post what that was, and again, this video is required, and the next video on specials is also required. Guys, have a good day.